Now we will solve our first problem on rigid pavement design using AASHTO method of pavement design. This math is 100% of using charts, uh, considering all the parameters. So when you are designing a rigid pavement, you need traffic consideration. We consider it in terms of ESAL, and you need to know the underneath soil condition. For that we have subgrade reactions. We denote it with kappa, and you have loss of support. Let's study a little bit of this, what is loss of support, but we'll consider it as a parameter. If I say it simply, it's just says if we are considering sub base or not, and it has a range of values, probably 0 to 1. If it is 0, we don't consider there is any sub base. We just say we are laying our concrete slab on subgrade directly. However, then we'll consider concrete parameter, as we are using concrete materials for our slab on which traffic will move on. And you have a elastic modulus of concrete 5.1 into the power 6 psi, and you have load transfer coefficient. Again, study a little bit on it. What is load transfer coefficient? It is just how efficiently the load is transmitted to the layers. And you have drainage condition. It is how effectively the water on the surface is drained. If it is like 1 or 1.2, it indicates that it's a good road drainage system. And if it is less than 1, it says that the drainage condition ain't good. And it is actually the inspections, considering specifications. Then you just name it 1 or 1.2 or zero point 0.4. There is no direct measurement, it's just inspection. And we then use that inspections, and we just numbers that, and then we use it for quantification. And you have change in serviceability index, that is 1.8. You have initial serviceability index. It means initial serviceability is kind of 4.1 or 4.2, which means the road is in good condition. If it deteriorates from 4, if it comes to around 2, then we consider that the road ain't that good, and we limit that. We don't want that to reduce it by 2.5 or below that. And you have a difference between the initial road condition to the terminal condition, what you want. Well, that is actually totally depend on wearing tearing of road due to the axial loads, and the soil parameters that changes. It may freeze on thaw, and it may, what can I say, heave, frost action, soiling, this thing kind of things that can happen. For that, serviceability index deteriorates. And you have reliability and standard deviations. These are statistics for the ESL you're using. And typically, we want reliability of 95% or above for highway, and you have a standard deviation for 0.29 for. I'm not, uh, there are some standards. Well, for that math, the reliability is 96, and standard deviation is that. We will consult a chart for this math. This chart is based on empirical formulas, maybe. We'll consult that. And the process is really long, really long. Well, first of all, we'll focus on effective modulus of subgrade reaction, and that was in our math, it was 280 pound per inch cube. So we'll see where 280 lies. You have 100 here, and 200 is the 200 maybe 200, 300, 400. Yeah, it's 200, it's 300. This is 300, and there are some values like I did 290, 280. So we have got our thing, and you have a concrete elastic modulus. In our case, concrete elastic modulus was 5.1 million pound per inch square. So we can use uh, this graph, this line right over here, and you have a value something right over here, and we'll draw a line connecting these 2 points. Let's say from here to up to this line. Then we'll extend up to this. Well, later the thing is, you have modulus of rupture for concrete. It's the concrete parameter, and yeah, and the value was for our case, if I'm not wrong, it was 650. So 650 lies somewhere over here. So we'll just connect that. We'll touch this turning line right over here, and from that we'll consider now traffic transfer coefficient, load transfer coefficient. In our math, load transfer coefficient Z was 3.3. Let's say 3 point is 2.2683, 3.2. Let's say the value is somewhere over here, so we'll just connect that. Let's say it goes like that. Now we'll consider drainage coefficient. For our math, the drainage coefficient was 1. So we'll touch this point, and then I will touch point 1, so which is this, and you'll get a value like that. So you have a match line, and you have say you just have got a value of here, that is and how much it will be. Let's say 72. It's just a value, it doesn't have any unit. So from the previous chart, we got the value of uh, match line, that was 72. uh, 72, that might be somewhere this 670, this 80, so in between, maybe this point right over here, 72. And you have reliability of 95%, and you have a standard deviation of, for this math, sorry, it was 96%, so that would be it don't matter much. So well, this is 99, so let's 96 would be somewhere over here, and there is 0.29 it was, so this would be the another point right over here. And you have a ESL value of 5.2 million, so this is 1, this is 2, 3, 2, 3, 4, 5. So you have 5.2, so that would be somewhere right over here. So 5.2. And you have a design serviceability of until the psi was 1.8, so it would be near 2. So this is 1, this is 1.5, this is 2, so the value would be somewhere right over here. So what you will do, we'll zoom it a little bit so that we can get a better view. So let's connect these points. You have a point right over here, and you have this, and you will go like this, like this. Fine. Later, we'll go a little bit down, and we'll come from reliability and standard deviation. We'll, let's say, connect this point and standard deviation point 3, and from there you have, let's say, 5.2 up to this 5.2, so this point, and from there we'll extend two straight line from both direction, and the intersecting point will tell us the depth of our pavement. I don't want to spoil this. I made some mistake previously. Well, so a line will go like this and would come, let's say, up to this, and another line will go and intersect like this, and the intersecting point is this, and this point is our intersecting point, and it lies in between 9 and 10. So we can say that the depth is 9.5 inch, or you may use 10 inch, no problem. So the design of rigid pavement is just the uses of church, and you just consult church and you can find out the depth of any rigid pavement using